Here, and let's learn about dilations. Dilations. Okay, so we're going to talk about dilations. Let me get my pen ready here. And before I go through this lesson here, let me go to a new page here real quick. If you have an eye, draw my best looking eye here. Now, if they talk about your eye is dilated, what they're talking about has to do with the size of the what is that, the pupil, I guess? I don't know. What's the dark part? Somebody can help me. I'm a math teacher, not a science teacher, okay? Don't know what it's called. But this part, when it gets dilated, it gets bigger, right? You can have it get smaller, you can bigger. If there's a bright light, it gets smaller. If it's really dark, it gets larger. Color this in here, right? And people talk about, oh, his pupils are dilated, right? So a dilation is something that goes, it's the same shape, right? It's still a circle in the center, but it's not the same size. Okay, so it's the same shape. It was a circle, small circle. Now it's a bigger circle, right? If it's really dilated, right? If you dilate something, it just gets bigger and bigger and bigger and bigger and bigger, right? So that's dilating it out. Okay, that's the idea behind the word. Okay, when we talk about dilations. Dilation is a similar transformation that enlarges or reduces a figure proportionally. This is going to be an important word for this whole section. Dilations are completed with respect to a center point and a scale factor. Okay, so a dilation has to do with a center point and a scale factor. So if we're going to draw the dilation of this triangle ABC with the center 0 or O. That's not a 0, that's an O. And the R, this R is representing the scale factor. So this scale factor is going to be represented by this number we're going to call R. So what you're going to do, and I'll see if I can even fit this in here. What you're going to do is you're going to say, okay, I'm going to measure, and you can use a ruler. Let me try that again. Use a ruler to measure from here to here. So whatever this distance is right here, we're going to double it. Okay, so it was this, now we're going to double it. So this distance again. All right, now I'm going to do this distance to this A and again. Okay, and then the distance to the C and again. Now, if you do this right and you actually use a ruler, it should look like exactly the same shape, but bigger. If it's a scale factor of 2, it should look exactly twice as big, right? This is my new A, this is my new C, and this is my new point B. And so we put a little apostrophe next to it and we call it prime. So the way that we're going to enlarge something, right? So if the scale factor is 2, 3, 4, 5, it's like saying two times bigger, 3 times bigger, 4 times bigger, and it doubles it, triples it, quadruples it, whatever the number is. Okay. But one way that you can do that is that this doubles. It would also be true that this side, if the length of this side was 3, the length of this side right here would be 6 if it's doubled, right? If this is 4, this would be 8, right? If this side was 5, this would be 10. So in an enlargement, if it's doubled, one way you could do this dilation, using the scale factor with the center point to show where it's going to be, but it also doubles all the dimensions except the angles. The angles remain exactly the same. If this was a 90-degree angle here, it would still be a 90-degree angle there, right? Whatever this angle is, it'd be the same measurement here. Whatever this one is here, it'd be the same measurement as this angle here. So the angles stay the same, but the sides either enlarge or reduce proportionally. Okay. All right. So that's the basic lesson. After this, you're going to try a few examples. We're going to do a few more examples together. These exercises in the study guide, and hopefully this will set you on the right path as you get through the study guide. All right. If you have questions, come see Mr. Harmless or send them to me if you're doing